Howdy, let's look at day 3 of our unit on circles. And to begin, I'd like to do a warm up with what we talked about yesterday. So you can look in your notes book and work this problem on your own, or you can work it along with me right here. This one says solve for x, so I need to add up all of these measurements of the arc, and they should add up to 360. So if I start over here and work this way, I've got 50 plus negative 2x plus 8 plus 130 degrees plus 150 degrees, and that should add up to 360 degrees. So when I look at these parts, those right there, let's see, that's 200, 330, 338, 338 degrees minus 2x equals 360. And so if I subtract 338 from both sides, I get negative 2x equals 22. And so x is negative 11. As we did before, I'm going to check this in my calculator. And so I'm going to start again with the 50. And so I've got 50 plus negative 2 times 11. Sorry, negative 2 times negative 11 plus 8 plus 130 plus 150. That should be 360. It is. Looks like I'm doing it right. So today, when we talk about circles, we want to talk about arc length and sector area. Now, we talked yesterday about the measurement of the arc, but now I want to talk about the actual length of the arc. And so the arc length is a piece of the circumference of a circle. If you think about it, it's the crust of the pizza. The crust goes around the outside of the circle, so that's the circumference. The arc length is a piece of that crust. So just to give you an idea, if I had a small pizza that looked like this, I could talk about this being 90 degrees. And if I had a big piece pizza, I could still talk about this being 90 degrees. But obviously in the big pizza, that's more crust. And so now we're not just talking about 90 degrees like we did yesterday. We want to actually measure the length of the crust right there. So the length of that arc. And a sector, similarly, is a slice of the area of a circle. So it's the inside part of what's going on with that circle. And so if this is the center of the circle, this piece of pizza or this slice of pizza is called a sector. The arc could be this, and I can measure it in degrees like we did yesterday, or what we're going to do today, we can measure the arc length. So the formula for the arc length is the circumference, 2 pi r, times however much of that circumference I want. So if I had 90 degrees, 90 over 360, that's 1/4. 1/4 of the circumference would be the arc length. So I'm going to make a little fraction with the measurement of that arc in degrees and multiply it by the circumference. Likewise, if I want to find the sector area, I'm going to take the formula for the area and multiply it by its fraction or its percentage that we have here. So number 1 says find the arc length of arc EF. We might write that like this. Sometimes when you type it, it's hard to make that little symbol, so we'll write the word arc. And so I'm looking for the length of this right here. So I'm going to refer to my formula, this formula right here. I'll rewrite it. It's 2 pi r times theta over 360. And as a reminder, theta is a Greek letter, and we usually use it to represent the measurement of an angle, or in this case, of an arc. So we've got 2 pi, the radius is 6, times theta is 120, so it's 120 over 360. The radius was 6, theta was 120. So now I have this that I'm going to type into my calculator. So I've got 2 times 3.14 times 6 times, and now we'll do a fraction, alpha F1, hit enter for fraction, and it's 120 over, oh, wrong button, 120 over 360. 12.56. Now that is the area, or sorry, that is the length of this arc. So I'm going to put some units on here just so we see. If this was in inches, then this would also be in inches. The units are going to be the same for the arc length. Now this one says let's find the area of the sector. We'll still call this inches just so we can keep that in mind. The units for the degrees are degrees. That's what that means. And so now the formula for area of a circle is pi r squared. And we want to multiply that by theta over 360 to find the area of the sector. So the radius is 6, theta is 120, and so it's pi times 6 squared times 120 over 360. So on my calculator, I'll go 3.14 times 6 squared times, again, we'll do the fraction, where it's 120 over 360, 37.68. And this is area. It's the area of this piece of pizza or this sector. So when I get 37.68, it's area, so it's square units. So let's look at this one. It says if the diameter of a circle is 20 centimeters and the angle at the center is 115 degrees, find the area of the sector and the length of the arc. Draw a picture. Okay, this is 115 degrees, so it's a little bit more than a fourth of the circle. So I'm going to draw the center on here, and I've got this and a little bit more than 90 degrees. So this is 115 degrees, which of course means my arc has a measure of 115 degrees. It told me that my diameter was 20, which means that my radius is 10. This is 10 centimeters. And so to find the arc length, I'm going to use 2 pi r, the circumference, times theta over 360. To do the sector area, it's going to be pi r squared times theta over 360. So for the arc length, it's 2 pi 10 times 115 over 360. So my calculator, 2 times 3.14 times 10 times 115 over 360. 20.06. And this is in the same units of the problem. So this is 20.06 centimeters. For the sector area, it's pi times radius squared times 115 over 360. So on my calculator, I've got pi times 10 squared times 115 over 360. 100.31. and this is in centimeters squared. It's area, so it's square units. So this gives you a good idea on how to work these problems. You can try them on your own now, rewatch the video for points that you need clarification on, and certainly communicate with your teacher if you need any help. Good luck and go Cougars.